All right, hello and welcome. This is going to be the lecture video for the acid and base test review. I don't have my tablet, so I'm going to be mostly just saying my answers and then just writing a few things with my trackpad. So hopefully that still works for you. Let's get started with number one. When an acid is added to water, the amount of blank ions increase. That's going to be H plus ions. H plus ions are going to increase. Additionally, acids can be defined as proton donors. We should say donors right there. All right, hydronium ion, how is it formed? So a hydronium ion, here I'll attempt to write it. It's an OH minus. So it's half of a water. It keeps the oxygen and then one hydrogen. How is it formed? It's formed when water splits in half. It goes through a process called autoionization, which just means to split yourself into your ions, or it can come from a hydroxide. So a hydroxide like NaOH can donate a hydronium to a solution. When a base is added to water, the amount of hydronium ions increase. So just use the word from problem number 2. Additionally, bases can be defined as proton acceptors. So acceptors is what we want to put right there. All right, properties of acids and bases. So acids, the ones that I want you to remember is that acids are sour and they're sticky. So think of lemonade when you think of acids and how lemons are sour, and then lemonade, if you spill it, is going to be sticky. All right, bases, what I want you to know is that bases are bitter and they're slippery. So you would never want to drink bleach, but bleach is very slippery. And if you ever did drink it, I imagine it'd be very bitter, and then you would die because bleach is also very poisonous. All right. Use the pH scale to answer the following questions. What's the pH range for acids? Technically, it's anything less than 7. 7 is the cutoff. 7 is neutral. So less than 7 is an acid. pH range for bases is anything greater than 7. So we can use an inequality symbol here to show that the pH must be greater than 7. And then for a neutral solution, the pH equals 7. And there are some cutoffs for like a strong acid versus a weak acid. But as long as you just remember this basic, less than 7, greater than 7, equal to 7, I think you're going to be okay. All right, if the pH is 5, what's the pOH? There's a rule here that says the pH and the pOH have to always add up to 14. So the pOH would be 9. That way they add up to 14. Same thing for E, but now to make it add up to 14, we need it to be 3.8. That's an 8. And then we were already using it, but complete the following equation. pH plus pOH always equals 14. All right, what is an indicator? What information can it give? It's a chemical that changes color with pH. And so the key information that gives us is it gives us the equivalence point of a titration. All right, generic equation for a neutralization reaction. So here, I'll try to write this. So you've got an acid, which we'll represent with an HA. We're going to mix that with a base, and the acid and the base are going to cancel each other out. So how we represent the base is BOH. So HA plus BOH, what's it going to create? It's going to create a water molecule, so H2O. And it's going to create a salt. And we typically write the cation first, so the salt would typically be Ba. I don't really care too much about the order here. It's just that everything that didn't make the water creates the salt. All right, so this could be hydrochloric acid plus sodium hydroxide. We would make water plus sodium chloride, NaCl. pH of the products of the neutralization reaction, well, it was neutralized. So if it was a strong acid with a strong base, it would be 7. Now I'm not going to test you on this, but if you did a strong acid with a weak base, the neutralization would still be a little bit acidic. It'd be slightly above 7. If you did a strong base with a weak acid, it'd be, well, that's the one that'd be slightly over 7. With a strong acid, it'd be slightly less than 7. All right, let's balance these reactions. So how many water molecules can we make here? I see 1 hydrogen, 1 OH. So I can make a single H2O. All right, and then whatever's left over is going to form the salt. So I've got a lithium and a bromine. Those just to come together to make lithium bromide as our salt. LiBr. Now this next one, I've got 2 hydroniums when this calcium hydroxide disintegrates. And I've got 2 hydrogens. So I'm going to make 2 water molecules. So 2 H2Os. And then everything else just makes a salt. And I'll put the calcium first because it's first in its molecule. It's the cation. It stays first. And then the SO4. All right. Now this next one's a little bit tricky because the hydrogen chloride or hydrochloric acid is only going to bring 1 hydrogen, but magnesium hydroxide brings 2 OHs. So I have to put a 2 over here. Don't miss this 2 over here or else it's never going to be balanced. With this 2 over here, I'll have 2 hydrogens, 2 hydroxides, so I can make 2 water molecules again. When we neutralize it, H2O, that says H2O, and then everything else comes together. It's going to be Mg, but because I had to put that 2 over here, there's going to be 2 chlorines in this salt molecule. So MgCl2. All right. Label the following as acid, base, or neutral. pH 3.4, that's less than 7, so it's an acid. pOH of 12. Well, the corresponding pH would be 2, so this would still be an acid. Don't be tricked here. High pOHs are very acidic. Slippery, that was a base. Acids were sticky, think of lemon juice. If the hydrogen ions is greater than the hydronium ions, that's an acid. Proton donor is going to be an acid. It's going to increase the amount of hydrogen in the solution. This is phosphoric acid, so that's just an acid. H2O, neutral. It's always neutral. It brings equal parts hydrogen and hydronium whenever it autoionizes. Soda and fruit juices, yep, acidic. Sodas because of carbonic acid, fruit juices because of citric acid. If these are equal, then it's neutral. Hydrogen ion acceptor would be a base because it'll decrease the amount of hydrogen ions. Products of the neutralization reaction should be neutral, except for the exception of a weak acid and a strong base or vice versa. This is a base right here, potassium hydroxide. Turns bright pink in phenolphthalein. Think back to our experiment. It turned bright pink when we added too much of the base. And then hydrogen ions less than the hydronium ions, that's going to be a base as well. All right, next page. All right, how we're going to label these. This H2SO4 is clearly an acid. For one, the H is on the left-hand side and it's by itself. So it's definitely an acid. And then what's it being mixed with? Well, this is our quintessential base, essentially, is NaOH. So that's our base. But we know it's a base because the OH is on the side and it's going to be lost together, the O and the H together. Now this is water and this is our salt. The salt could be split apart into just an Na by itself, which would be the conjugate acid, or an SO4 by itself, which would be the conjugate base. All right. So now we've got an example of a titration. Let's see if we can figure this out. So we're titrating hydrochloric acid using sodium hydroxide. We used an indicator of phenolphthalein, and NaOH was in the burette. Write the neutralization reaction for HCl plus NaOH. So those, it's just, they're both have only one proton or hydronium to give. So they'll just make one water molecule when those two combine. And then we're going to make our salt, which is NaCl, which is good old-fashioned table salt. Although I wouldn't trust it if you're making it out of such strong chemicals. All right. Initial volume. So we need to be able to read this meniscus. let's see, 0 is up here, 1 is down here, and then I'll just count them, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and then a half. So I can go to the second decimal point, 0.75 milliliters. All right, final volume looks like 49.35. So 49.35. So total volume, I need to subtract these two. And I get 48.6 milliliters, which when I divide by 1,000 is 0.0486 liters. You could also think about moving the decimal point 3 times. All right, so then moles of NaOH. So I'll take my liters and multiply it by the concentration, which I find up here. This was 0.5 molar NaOH. So 0.0486 times 0.5 gives me 0.0243 moles. All right. Original volume of NaOH. We look back at the problem. Reread intro. I think this was copied out of the lab because it does not tell us the original amount. So what should we say? 10 milliliters? Let's say 10 milliliters. And then we convert that to liters. That's going to be 0.01 liters. All right, so molarity of the HCl. So the moles of NaOH is going to be equal to the moles of of HCl because it's a 1-to-1 relationship. So we just have to take the same number of moles and divide it by that liters. Because I picked 10 milliliters, I made the math easy because I'm doing this number here, the 0.0243 divided by the 0.01. And so that's just going to be, move the decimal place twice, 2.4 molar. So 2.43 molar. Again, moles over liters. So I've got moles right here. I've got liters right here. Just divide them to get that molarity. How do you know the titration is complete? Because we are putting base into acid, the solution should be clear when it starts, and then it's going to turn pink. Just like in the lab we did, it turns pink. All right. Number 11, how does an antacid tablet alleviate issues from heartburn? It helps to neutralize your stomach acid, which is causing the chemical burn in your esophagus. So by neutralizing that acid, the chemical burn should stop. Takes a while, but they do work. Number 12, molarity of hydrogen ions in a solution will have a pH of 4.5. So to rearrange this, to get the hydrogen ions by itself, we can use a slightly different formula where it's rearranged. Concentration of hydrogen ions, H+, is equal to 10 to the power of the negative pH. So I'll plug in the 4.5 and then use my calculator to simplify. And I get 3.16 times 10 to the negative 5. My calculator gave me a number with a bunch of zeros, but I used scientific notation to move the decimal place to right after the 3, and I had to move it 5 times. So that's how we got the scientific notation. What a buffer is, it's an acid mixed with its conjugate base, and it works to resist change in pH. All right. So that's that for this lecture video. Good luck in the test. Have a good rest of your day.